Hi, I'm Cathy Fang, and on behalf of my collaborators Suzuki and Daniel Leithinger, I'm presenting our late-breaking work on an idea called VR Haptics at Home, which repurposes everyday objects as passive props to create haptic feedback. With the commercialization of mobile VR devices, users are no longer tethered to the computer and thus can use VR wherever they wish. However, VR haptic experiences are not the case for such casual and on-demand use. What if, instead of excluding indoor furniture and obstacles, we could turn over everyday object into an adaptable, easy-to-use, and body-scale VR environment? To investigate the VR Haptics at Home concept, we developed a proof-of-concept prototype. The user first places the object of interest at a desirable location and then aligns the controller with the object. Then they press the trigger to place the virtual object. The user then sets aside the controller to allow the system to automatically switch to hand tracking mode. In this example, the cushion is repurposed as the cat's belly, and the user receives haptic feedback from the cushion as they pet the virtual cat. In this whack-a-mole game, a tabletop is used as a game platform, and the user feels their hand hitting the virtual moles. One can also substitute a chair for a cannon, where the user rests their hand on the back of a chair and moves it around as they rotate the virtual cannon to aim at the monsters. The idea of leveraging passive haptic prop itself is not new, and it has been explored in the literature most known as substitutional reality. However, most prior work has been studied in a controlled laboratory setting, leaving questions about how this approach can be adapted to various rooms in real-world environments. We conducted an in-a-wild study with 8 participants at their home and offices to play the 3 scenarios we developed. The study results show that our method can be adapted to objects in different homes, and then the extra steps to configure the objects are considered to be minimal and easy to follow. In addition, while some tasks were more negatively affected by imprecision in hand tracking than others, overall, our method can effectively provide haptic feedback and enable more engaging VR experiences. Through the participants' feedback and iterative design process, we explore the possible design space based on the properties of the object's environment. For example, characteristics like mobility depends on the object's weight, size, and relation to the indoor environment, which provides constraints to the possible interactions. We also found that not only the shape but also the affordances of objects, such as compliance, mechanism, and texture, could enhance rich tactile feedback for passive haptics. Please see our paper for full detail.